So topic today, we're going to be graphing parabolas. Shh, stop talking. You're live, so if you're talking away, you're on film. Okay? Graphing parabolas in vertex form. Okay, write that down. We're going to be graphing parabolas in vertex form. Okay, so vertex form is really, we just got done taking a quiz, and on our quiz, we just got done graphing parabolas, right? And we had to come up with the negative b over 2a, right? If it's in vertex form, it's much easier. So there's two forms for parabolas. One is what we call standard form. This is standard form. And the other is what we call vertex form. Now, here's what the vertex is. If it's in this form, this quantity squared, then the vertex is already in the problem. The answer is already in the problem. So if I take a look at example 1, the vertex is going to be negative 3, 2, because it's going to be the opposite of the inside, okay? So the vertex, remember how we had to do the negative b over 2a? This is so much easier. It's in vertex form. Vertex form is the quantity squared, and the vertex is just the opposite of that number, and then that number. So negative 3, 2. There's your vertex. That is either the lowest or the highest point of my parabola. Okay, it's as easy as this. It is the opposite of that number with that number. That's our vertex. It's that easy. It's the opposite of this number. Now, the reason it's the opposite number is, think about this. I don't care if you know, but I'm going to tell you anyway. The reason it has to be the opposite is because the vertex is the lowest point. Agreed? It's the lowest point. What number, or the highest, what number would zero this out to make it the lowest? Negative 3. Negative 3 would zero it out to bring it to its lowest point. That's why it's the opposite, because it brings it to its very lowest spot. Okay? Now, we know how to do this from here, because if we're going to do a x squared, remember how we did the, what's 1 times 1? 2 times 2? 4. 3 times 3? 9. Okay, negative 1 times negative 1? 1. Negative 2 times negative 2? 4. Negative 3 times negative 3? 9. So if we start at the vertex and go over 1, 1 squared is 1. We go back to the vertex, which is the lowest point. If I go over 1, 2, 2 squared is 4. 1, 2, 3, 4. I go back to the vertex. I go over 1, 2, 3, and 3 squared is 9. Now, 9 is going to be off my graph, but I'm going to find it anyway. I'm going to estimate 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to estimate up here. We also know that our parabolas have lines of symmetry, right? And our lines of symmetry must go through my vertex. So then we have the reflection of these points on the other side of the line of symmetry. So we also have a point here, because that's negative 1 times 1, negative 2 squared, and negative 3 squared. So there's our parabola. Much easier to graph it when it's this form than what we did on our quiz. So if it's in vertex form, we're like, sweet, this is easy if it's in vertex form, right? So much better, isn't it? Now, getting into vertex form is hard, but we will not do that today, okay? Okay, we're going to leave it in vertex form. Every problem we do today will be in vertex form, which makes it pretty easy. Yes, Landon?
Is that always like 1 squared, 2 squared, 3 squared?
Yes, because the problem is a square.
Oh,
right? If it was a cubed, we do it differently, right? But because it's squared, yes.
But
so
it says the y-intercept is 2.
Our y-intercept is up here somewhere, right?
Oh, but then what's the 2?
It's the y value of my vertex. So my coordinate here is a negative 3, 2, right?
Okay.
So let's look at number 2. What is the coordinate of the vertex?
2, negative 4.
No, yeah.
2, negative 4 is correct. Who said that? Yeah, nice job, Saul. So Saul did the opposite. All right. So my coordinate is at 2, negative 4. 1, 2, 3, 4, right? You guys got it? And now, Landon, because it is squared, we'll do our 1, 1, our 2, 4, and our 3, 9, right? From our vertex, though. From our vertex, because that's our lowest point, right? Over 1, up 1. Go back to your vertex. Go back to your vertex over 1, 2, 2 squared is 4. 1, 2, 3, 4. Okay. Go back to your vertex. Go over 1, 2, 3. 3 squared is 9. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. Now we know, because it's a parabola, it has a line of symmetry that goes right through the vertex, right? It's got a line of symmetry right there. And we know that all of these points, hi guys,
Sorry, we just
are,
talk to Cole real quick.
I'll make it real quick, I'm recording, okay? So we reflect the points over, right? Reflect the points over and over, okay? There you go. Okay, easy?
No.
Yep.
I do. I do.
Thanks, Cole. Thank you, Mr. Davies.
Zoe.
Oh, thank you.
I've been trying to do that.
Alright, guys, ready? Since we got interrupted. Alright, let's finish this up. So, let's go back to example 3. Everybody okay on example 2?
Sure.
Okay, I took the opposite. I went 2, negative 4, okay? Only the opposite of the inside. Just the opposite of the inside, okay? And then when I graph my vertex, I know it's a squared, so I'm going to go my 1, 1, 2, 4, 3, 9. It has a line of symmetry down the vertex, so we know that all of those points are reflections over the line of symmetry. And so then we just map the other points on the other side of the line of symmetry, and we graph in our parabola, okay? Now, when we get to example 3, there's one thing different, and that is the 2, okay? Now, the 2 makes this one twice as tall. Write that down. Twice as tall. Okay, write that down. Now, it doesn't change the vertex. The vertex is still the same. The only difference is it's going to be twice as tall. So the vertex, what is the vertex? What is the vertex?
Thing that goes down the middle.
1, yes. 1, negative 3 is correct, and it is the very bottom point. So I go to 1, negative 3, and there's my vertex. Okay, everybody okay with that? Now, if it's twice as tall, listen carefully. 1, 1 becomes 1, 2. 2, 4 becomes 2, 8. 3, 9 becomes 3, 18, which we probably won't be able to graph the 18 because it's going to be too high. Okay, we're going to have twice as tall.
So
1, 1.
we just, so the y?
The y's are greater because when you get this answer, it's a y answer. Check it out. When you get this answer, Landon, it's a y answer, isn't it? Right? So instead of doing 1, 1, we go twice as tall. We'll go 1, not 1, but we'll go 2. So the point would have to go right there. 1, 2. Okay, so you went right there. 1, 1, 2. Twice as tall because it was 1, 1, but twice as tall. Now I'm going to go 2, what? Normally 4 because 2 squared is 4, but 8 is correct. Well, it's 2, 4 because 2 squared is 4, but I'm going to go, instead of 4, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And I would do 3, 18, but it's off my page. You guys agree? It's not worth putting down, right? So I have a line of symmetry that goes down the middle, right? Here's my line of symmetry. We know we have points that reflect the line of symmetry, so I'm going to go ahead and graph my reflected points. I didn't get my 3 18s because it's off my graph. Now it should be skinnier because it's really taller, isn't it? Okay. Yeah, there you go. Okay, now example 4 has a negative right here. So what the negative does on the outside here is it just simply makes it a reflection. It's going to be a reflection over the x-axis or upside down. We'll write both. It is a reflection over x-axis, or better yet, we're going to just say it's upside down. It's a frowny face. Remember we talked about the frowny faces, and the frowny faces came from negative x squares. Well, this is a negative x squared, okay? Doesn't change the vertex at all. Doesn't change the vertex. So what is the vertex? Positive 3, 5.
It's already a negative.
The negative's on the outside. The negative's on the outside. So we always do, remember?
But still, it multiplies by a negative.
Not until you can add these or subtract these, which you can't. because it's quantity squared, right? So you can't bring the negative in, can you? Can't, because of the quantity. Remember your order of operations, right? So let's go to 3. 1, 2, 3, 4, 5. Though Price, I like it when you ask those questions because those are good questions. Good questions, okay? Now, we're still going to do our 1, 1, our 2, 4, and our 3, 9, but the difference is we're going to go down. Does that make sense? So I'm going to do my 1, 1, but I'm going to go down 1 because it is a reflection. I'm going to do my 2, 4, but I'm going to go down 1, 2, 3, 4. I'm going to go 3, 9, but I'm going to go 3, and I'm going to go down 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So right about there. Again, I know I have a line of symmetry which goes right through the vertex, right? So I will reflect my points over the line of symmetry, and I'll plot the reflection. And I'll plot the reflection, and there it is. So vertex form's pretty easy, isn't it?
No.
Okay.
I don't understand this.
All right. Better than negative b over 2a, right?
Yeah.
Okay, and we'll have an opportunity to practice this, which I can come around and help if you're having a difficult time with it, okay? Ready to turn the page? Okay, I'll wait for you. You can't see it? Yeah, I'm sorry, Cooper. No, I tend to get in the way. Okay, turn the page. Ready, set, here we go. Okay, now, so example 5. Now example 5, the only difference is I'm going to ask for all of these things that normally we always do. Easiest way to do it is to first graph it and see if we can get the stuff from the graph, okay? And if we can't, then I'm going to talk about how we get them. So first of all, right off the bat, what is the vertex?
1, -4.
1, -4 is correct. Okay? It's the opposite, right? It's the opposite of that -1 is a positive one, okay? So we're going to have our vertex at 1, -4. It's a smiley face, right, Price? It's a smiley face because it's got to be a smiley face because of the positive. So we know that it opens up. It has to open up. And I say that because there's a positive one right here. So it has to be a smiley face, right? Opens up, right? If that were negative, it would go down because that's positive goes up. We know that, okay? Now, our line of symmetry. And Nikolai, you actually said it earlier. The line of symmetry is one that goes through the middle, right? So our line of symmetry is x equals 1 because it goes right through the vertex, right? It has to go right through the vertex, right? Let's do our 1, 1, 2, 4 and see what happens. 1, 1, 2, 4, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll reflect our points over the line of symmetry. So we'll have a coordinate there. We'll have a point there. We'll have a point right there. Okay, we can draw our parabola in. Okay. And now we can actually answer the next two questions, right? Okay, our next two questions are going to be, well, the y-intercept is right there, correct? That's my y-intercept. So my y-intercept is at, how about 0, -3, but you got the right idea. Yes, yes, you got the right idea. My x-intercepts
Why
are,
is it that?
it's that point right there.
But why can't it be any other dot?
Well, y-intercept means where does it cross the y-axis? Where, that's what the y-intercept means, okay? Crosses the y-axis right there. So Nikolai, the x-intercept would be where it crosses the x-axis, which has to be,
Doesn't at all cross it.
then you'd say there is none. And that happens, that can happen, okay, if it's above it. Okay, so now, x-intercepts, okay? X-intercepts, there's two of them. And the x-intercepts are, you ready? There and there, right? There's my x-intercepts. And so they are at -1, 0, and 3, 0. Okay? Now, write that down. And we're going to talk briefly about if you can't get it from the graph. So very briefly, y-intercepts, write this down. Let x equal 0. And write this down. We don't need to do this on this problem because we found it from the graph, right? But if you can't find it from the graph, you need to do this. And the x-intercepts are let y equal 0 and factor, okay? Which you guys are getting good at factoring, okay? Well, we're going to keep practicing factoring, okay? Thumbs up so far. Now, here's what I don't like is example 6. Example 6, the only thing we can get easily from example 6 is the y-intercept. That's it. It's in the other form, okay? See, I like vertex form because boom, you got the vertex right off the bat, right? If it's not in vertex form, then what we're going to have to do is our x equals negative b over 2a. So before I go any further, do you see the difference? I'll slide down. Do you see the difference between the two types of parabolas?
Yeah.
This one's the quantity squared. It's in vertex form. Vertex snap is easy. I like vertex form. This is in what we call standard form. It means, dang it, we got a lot of work to do. Okay, so negative b over 2a. So we're going to have to do the negative 2 over 2 times 1, right?
Wait, what's A? Is A 0?
A is 1,
Oh, yeah.
because there's a 1 right there. So A is 1, B is negative 2, and C is negative 8, right? So slide it up so you guys can see it. So negative B is negative 2. Great question. Yeah, this is what you still need to see, right? Right, Ben? This is the stuff you haven't figured out, okay? So I get a positive 2 over 2, which is a 1. So my line of symmetry is at x equals 1, right? So we just do our... Right? We did this on our quiz on Friday, right? So then, if we need our vertex, we know our vertex is 1 something, right? To get the something, we plug in the 1 into our original. So we're going to go y equals 1 squared minus 2 times 1 minus 8, right? 1 minus 2 minus 8, which makes negative 9. So my vertex is at 1, negative 9. Okay, I'll let you look at that. So I knew my vertex was 1 something. To get the something, I had to plug the 1 into the original, okay? And I did that. I went 1 squared minus 2 times 1 minus 8. Did the math, and I got negative 9. So my vertex is at 1, negative 9. So let's see if I can put that on there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right there, okay? Okay, the y-intercept. This is the only thing easy about this form, okay? The y-intercept is that number there, okay? Because if x is 0, right, if x is 0, 0, right, it's just negative 8. So my...
I thought that Y was just 1, negative 9 then.
That's your vertex. So you're okay, so every point has an x and a y value to graph it, right? A y-intercept is where it crosses the y-axis. So it crosses the y-axis right there at 0, negative 8, okay? And of course, the fact that it's symmetrical, I can put another point there, right? Right, I can put another point there because it's symmetrical. And finally, Austin put that phone away. Finally, x-intercepts. Yeah, you're ahead of me. If I set y equal to 0, let y equal 0 and factor, right? I'll have 0 equals x squared minus 2x minus 8. Now you cannot solve for x like that. You can't, because it's x squared and x. But that's why you factor, okay? Can't solve for x like that. But that's why we factor. We'll go x minus 4, x plus 2, right? But we want the values that make it 0. So obviously 4 would make it 0, right? Wouldn't 4 make it 0? And negative 2 would make it 0. But if you can't see that in your head, we make our little mini equations. Our little mini equation is 0 equals x minus 4 and 0 equals x plus 2. And if you solve, sure enough, you get positive 4 because you go plus 4 minus 2 minus 2, and you get, okay, so my x-intercepts are at 4, 0, and negative 2, 0. So it goes on the graph here, And 1, 2, 3, 4 here. Okay? Alright. Now, before I finish, the moral of the story is this. When it's in vertex form, it's pretty easy, isn't it? You guys agree with that? So vertex form is the easiest way to do these. If it's not, we've got to do all the other work that we've done before. And that's why I always like to teach this one first, so you learn that one. Yeah, Nikolai?
Are we almost, like, how many more tests do we have this season?